Yes, good evening everyone. Welcome you all to another session of chemistry. My name is Dikesh, Faculty of Chemistry, Brilliant Group, Doha. Guys, today we are going to discuss some important NCERT based MCQ questions from the chapter Chemical Kinetics. As you know, Chemical Kinetics comes under physical chemistry. So from this chapter, you can expect questions based on theory as well as numerical. So I selected some important questions which comes under the theory based as well as the numerical based. So it will be helpful in your upcoming board exam. So be active. You have to send the correct answer, right answer in your comment box. So be active. I'll be checking. So those who all are sending right answer, let's see. So active, be ready. Now we can start the session. So we can go for the question. Listen. So the first question is, the rate law for the reaction A plus B gives products is given as rate equals to K into concentration of A into concentration of B raised to 2. On doubling the concentration of A and B, the reaction rate is. You know the question is based on rate law, isn't it? So rate law is nothing but rate of a chemical reaction is proportional to the concentration of reactants. You know, this question can be solved based on the rate law. So we can write the rate law, small letter r equals K into concentration of A. Here the power is given, the power of A is 1 anyway, then B is 2. See, this is the given rate law equation. So in this rate law equation, they are asking what happened if the concentration of A as well as B when doubled. So we can double the concentration. C is equal to K is anyway constant. Okay, we are doubling the concentration of A means we can write 2A, isn't it? Power is anyway 1 only. Then B, when you double, you will be getting 2B raised to 2. Correct? Yeah. So see, now students are sending answer. Okay, right answer. Let me check. So here you know that one, K is anyway constant. 2 raised to 1 is 2 into 2 raised to 2 is 4. You know that one, you will be getting 8. So this can be taken as R1, means the initial rate we have. So we can write R1 is equal to 8R, which means if you are doubling the concentration of both A and B, the new rate will be 8 times than that of the initial rate. So initial rate is R, we consider, that is this one. Now we have a rate that is 8R. Clear? So 8 times than that of the initial rate. So let's go for the option. Remains the same. You know that one is double. It's an easy one. Okay, we can categorize this question as an easy question. So increases to 8 times than the initial rate. So correct option is D. Yes. Yeah, Dhruvil, so many. Yeah, Abin. See, we got correct answer. So yeah, the same way you send your right answer in comment box. We can check. Yeah, so many are sending. Yeah, correct. Very good. Very good. So we can go for this one, you understood. So this type of one question you can expect based on rate law. You know that one, this NCERT question. So this type of one question you can expect. Okay, shall we go to the next question? Fine. See question number 2. See, the second question is, for a zero order reaction, 0.4 moles of the reactant is converted to 0.2 mole in 2 minutes. See, while reading the question itself, you will get the idea 0.4 moles converted to 0.2. See, half of the reactant has been used up, which means they are giving half-life period. The time required for the conversion of 0.8 moles of the reactant to 0.2 mole. See, here no need to use any equation. I'll give you an easy trick. Okay, we can write the answer directly. Okay, so here you know that one, zero order reaction. Few things you have to keep in mind. Zero order reaction. So for zero order reaction, see, zero order reaction, you know that one, half lifetime is, means T half is directly proportional to initial concentration. You know that one, T half is equal to R0 divided by 2K. We learned that one. Which means when initial concentration doubles, T half also will be double. So here what is given that we can write first, see 0.4, which means now the initial concentration is 0.4. 0.4 converted to 0.2, see half. Which means this time period, the concentration changes from 0.4 to 0.2, that can be considered as T half. So T half is given. T half is equal to how much? 2 minutes. So here that T half time is 2 minutes. I will write over here. And for zero order reaction, you know that one, when you double the initial concentration, what happened to T half? T half also will be double. Yes, people are sending answer. See, let's see which one will be the correct answer. See, now they are saying what happened when 0.8 to 0.2. So 0.8 to 0.2 means we can write 0.8. First, we can take the half of that, 0.4. Then after that, already is given over here, 0.4 to 0.2, that's the half. No need to use any equation or anything. So 0.4 to 0.2 already is given, that is 2 minutes, isn't it? Then what will be for 0.4 to 0.8 to 0.4? It's double actually. 0.4, when you consider 0.8, it's a double of 0.4, which means the half-life also will be double. Why you can logically connect this? A zero order reaction is nothing but a reaction which will have same rate, okay, starting to the end. So a reaction which has a constant speed, we can say like that one. Constant means speed or rate will not be changing with the change in concentration, has the same speed. So here the initial was 0.4, 0.4 to 0.2 is 2 minutes. Now 0.8 to 0.4, how many minutes it will be? 4 minutes. We can write, okay, 4 minutes. So total is what? 4 minutes plus 2 minutes, that is 6 minutes. Yes, so many are sending the correct answer. Yes, half is well done. Dhruvil, good. I mean, see, we got almost all sent the right answer. Correct answer is 6. Yes, well done, good. So the option is D. Correct answer is 6 minutes. Hope you understood the logic. This is the way we can solve this type of one question, okay, for zero order reaction. Fine. Then we can go to the next question, third one. Third question is, the reaction A gives B takes place in according to zero order reaction. Again, it's a zero order reaction, a question based on zero order reaction, but it's a different one. Zero order kinetics, the time taken for the completion of the reaction is, again you guys can send the right answer. Okay, the time taken for completion. See, I gave an idea, in zero order reaction, speed or rate of reaction remains as the same. Yes, all are sending correct answer. Someone are sending B. Check your answer once again. If you are sending B means. So, listen, a zero order reaction half-life period is how much? You know that one, half-life period here. According to zero order reaction, you know that one, a zero order reaction will have how many half-life period? 2, right? For a zero order reaction, how many half-life period will be there? 2. So T half into 2 is equal to total time, T 100%. Hope you understood the logic. See, T 100% means what? For the completion of reaction. So for a completion of zero order reaction, it takes double of half-life, because the time, if it is 2 minutes means, we discussed for the previous question, no? If it is 2 minutes means half is gone. Another 2 minutes means same speed, no? Then the another half will be getting over, then the reaction will be completed. So for every zero order reaction, how many half-life periods are there? 2. So we can write for zero order reaction, total time taken is equal to T half into 2. And we have the T half equation I gave in the previous question, no? T half equation we have R0 divided by 2K. Isn't it? Or you can write A0 divided by 2K, both are same. T half is equal to A0. If you can take, if you are taking the initial, means the reactant as A, that is also same. A0 divided by 2K. Then you know that one, you have to multiply 2 over here because T 100% is equal to T half into 2. Hope you understood. Now we can cut 2 and 2. So is equal to R0 divided by K. Yes, yeah, so many correct answers came, but still someone sent A. Check your answer. So correct answer is what? R0 by K or A0 by K is the right answer. So we can write correct answer is A0 divided by K. Clear? So correct answer is fine. Now we can go to the third question. Sorry, fourth one. Listen. Third question is over. This is the another one. The rate, the unit of rate constant for a zero order reaction is. See, it's an easy one. We can categorize this question as an easy one because we have a general formula to find the unit of rate constant in nth order. You know that one, for any order of the reaction, rate constant means for different order, unit of rate constant won't be same. Unit of rate is same, but unit of rate constant is not same, isn't it? So unit of rate constant in nth order or for nth order, we have a general equation. What is the general equation? Do you remember? Yes, the nth order reaction is mole raised to 1 minus n, liter raised to n minus 1, and s raised to minus 1, where you know that one n is the order of the reaction. So here they are asking for zero order reaction. So for zero order reaction, we can write for zero order is equal to mole raised to, okay, 1 minus 0, yeah. So liter raised to 0 minus 1, then s raised to minus 1. So now we got the answer. So n is 0. That's why we substituted the value for n as 0. Now we will get mole liter raised to minus 1. Mole raised to 1 means mole only. Liter raised to minus 1. 0 minus 1 minus 1. S raised to minus 1. Correct, right? Yes. Most of the, all of you sent, I think, we got almost all correct answer from the chat box. It's, correct. Option is A. So mole liter raised to minus 1. S raised to minus 1. So correct answer is option A. Mole liter raised to minus 1. Second raised to minus 1. Fine. So the same way you send your right answer, it's fine. Almost all are responding. Very good. Dhruval, correct. So we can go for the next question. So question number 5. Yes. See, the question is, for the reaction A plus B gives products, it is observed that on doubling the initial concentration of A only, it's another type, rate law, based on rate law the question is, but not the same of the previous one, it's a different one. This type of one question also you can expect. It's a NCERT based, your reader based question. So on doubling the initial concentration of A only, the rate of reaction is also doubled, isn't it? So two conditions they are giving. Based on the condition, we can find out the order. Actually, that is what the question is. On doubling the initial concentration of both A and B, there is a change by a factor of 8. Okay, in the rate of the reaction. The rate of the reaction is given by, means reverse they are asking, we need to write the rate law expression from the following data. So just we can write the equation first. A plus B gives product. So we can write just as P. So general equation will be like this one. No, generally we can write rate law. R is equal to, rate is equal to K into, isn't it, concentration of A raised to X we will be writing. You know that one, whatever the coefficient of reactants, okay, doesn't matter. It is experimentally determined order of the reaction. So we will be writing A raised to X into B raised to Y. This equation we can consider. After that we can go for the hint what they are giving. Initial concentration of A only means on doubling the concentration of A only. So I will write it as this one, R1. Okay, R1 means, see, on doubling the initial concentration of A only, the rate of reaction is also double. Rate of reaction of also double means I can write it as 2R, right? So the doubling the concentration 2R. So 2R is equal to K into only A is doubling means I can write 2A raised to X into B remains as the same. So I will write B raised to Y. So this can be taken as equation number 1. This can be taken as equation number 2. Easily you can, yeah. Yes. Yeah, I'll come to the chat box. Wait, after solving this one. So 2R is equal to K into concentration of A raised to X into B raised to Y. Okay, and the second hint is on doubling the initial concentration of both A and B. So again, A and B at the same time, if it is doubling, it will be a factor of 8, in the sense it will be 8 times that of the initial rate. So here I can write 8R. 8R is equal to K into both has been doubled, so we can write 2A raised to X into 2B raised to Y, isn't it? Equation number 3. See, by considering these three equations or equating these three equations, you will be able to find the value of X and Y. That is what we are going to do. So now we have three equations. See how we will be equating this equation, or you can find the value. So if you are dividing equation number 3 divided by equation number 2, we will be getting the value of Y, because when you divide, so we can do over here equation number 3 divided by equation number 2. Wait, equation number 3 divided by equation number 2, if you are dividing, you know that one k will be cancelled, 2A raised to X, 2A raised to X will be cancelled, 2B raised to Y divided by B raised to Y is what? 2 raised to Y only, isn't it? 2 raised to, I'm writing directly, these all factor will be cancelled, 2 raised to Y, you will be getting 2B raised to Y, B raised to Y, you will be getting 2 raised to Y is equal to, we can write 8R divided by 2R. 8R divided by 2R is equal to 4. 8 by 2 is equal to 4. 2 raised to Y is equal to 4 means you can write that is Y is equal to 2. Hope you understood. We got the value of Y as 2. Clear? Now we will, the same way you can find out the value of X. To find out the value of X, again you can do one thing here. Equation number 2 divided by equation number Y. Equation number 1. Why we are choosing this one? Because here the B, V values are same. Value of B here and here in equation number 2 and 1, it's same. So equation number 2 divided by equation number 1, if you are taking, you know that one, the factor, yeah, these factor will be cancelling, B and B factor will be cancelling. Then you know that one, you will be getting 2A raised to X divided by A raised to X is 2 raised to X. 2 raised to X is equal to 2R divided by R. What will you be getting? 2R divided by R, you will be getting 2. Correct. So 2 raised to X is equal to 2 means that you can write X is equal to 1. Right? 2 raised to 1 is equal to 2. Now we have the value of both X and Y. You can do this one easily. This one I explained stepwise for easy understanding. Okay, so you can easily write by doubling this one, means you can write the power and you can easily solve this one. So now we got the value of Y as well as X. Now you can substitute into the general equation or the rate law equation. What is the general equation, rate law equation? Small letter r equals K into concentration of A. X value we got as 1, isn't it? Or generally we will write X1 means it's default 1 only. Then B value we have, Y value we have, so into B raised to 2. See, Y value we got. So correct answer is what? Option A. See, here it is. Rate equal to K into concentration of A into B raised to 2. So right option is A. Let me check who all got the correct answer. Yes. Yeah, correct one. Fifth one. Yes, A. Right. Yes, Joel. Fine. All you got the correct one. Yeah. No doubt, right? Yeah, okay, fine. So fifth question is over. So this type of one question, so while doing this one you can do directly, means you can write the equation and cut the value and write the X value and Y value, just substitute into the rate law equation, then you will be getting the value. Hope you understood. Now we are moving on to sixth question. Shall we go? Yes, Sohail Gun. So can you explain once again? Yes. Listen, this question is actually reverse. Reverse in the sense, they are giving the hint that concentration we are doubling. This is called an initial rate method. We have one calculation based on this one, initial rate method. The concept here we are using to find the answer. So here what they gave, A gives B, A plus B gives products, that is the equation. So we can generate, the equation is A plus B gives P. Whatever the equation, we will be writing rate law equation as general. You know that one, that rate law equation general I wrote. Small letter r equal to K into concentration of A raised to X into B raised to Y. Clear? So after that what they are saying, see, if you double only A, if you double only A means we are keeping the concentration of B as same. And I doubled B. See, that is I took it as 2R. 2R means that they gave, see, double. Rate of reaction will be double means I can write 2R because initially it was R. So double means I wrote 2R. Then only A has been doubled means I took it as A, B remains as the same. That equation I took it as 2. Same way, in the third, means in the second hint, they are saying doubling both A and B. Doubling both A and B means, you know that one, concentration of A as well as B has been doubled. So if you are doubling both, the rate will be a factor of 8 times. You know that one, rate always will be in times like initial, then this time 4 times or 8 times, 2 times than that of the initial rate. So initial rate is anyway, you know that one, R. So we took it as 8R because 8 times, factor of 8. How that factor of 8 came? When A is doubled as well as B is doubled. So A raised to 2A raised to X and 2 raised to Y. So you understood how we formed the 3 equation, right? After that we have to equate it. Equate means, you know that one, same values of B means you can divide. That's why I divided equation number 2 by 1. Then you know that one, A factor will be cancelled as well as K, rate constant K. After that, so B factor will be cancelled. Equation number 2 divided by 1 means B is same, cancel. 2A raised to 2A divided by A. That means I will get 2 raised to X. 2 raised to X is equal to 2 because 2R divided by R will be coming. 2R by R is equal to 2. 2 raised to X is equal to 2 means X value is equal to 2, correct? Okay, the same way I did equation number 3 by 2 because there the value of A are same. That's why I divided. Then I will get 2B by B. So 2B divided by B means this factor will be cancelled. Then I will be getting 2 raised to Y. 2 raised to Y is equal to 8 by 2. See, this dividing 8R divided by 2R is what? R become cancelled. 8 by 2 is 4. 2 raised to Y is equal to 4. Sohail, is it fine? Now once we get the value, we will be substituting. Clear? Now we can go to the next one. So all the type of question we need to finish today. Okay, some questions are in easy category and some are in moderate, some are difficult. Numericals means, you know that one. A few questions will take time. Okay, shall we move on to the next one? Fine. Here the correct option is A. Now we will go to the sixth one. See, the sixth question is, again, if the rate of a reaction is equal to the rate constant. That is an easy question only. If the rate of a reaction is equal to the rate constant, the order of the reaction is. Yes, those who know the answer, please send your right answer in comment box. I'll be checking. Yes. So correct answer for this one. See, you know that one, this question, it's again based on the rate law. Rate law means, you know that one, but it's a different question. You know that one, small letter r is equal to K into concentration of, we can write A raised to X into B raised to Y, this equation. Here they are asking in which order both rate and rate constant become equal. Okay, rate of the reaction is equal to the rate constant. Rate of reaction is equal to rate constant means, you know that one, these factors should not be there. These factors should not be there means A factor, then we can write like this one, small letter r is equal to, let us assume, if concentration of A power is 0. Okay, what if the concentration of power means the power values are zeros? You know that when any value raised to 0 is equal to 1, right? Then you can write here, that is small letter r is equal to K because A raised to 0 is 1, B raised to 0 is 1. Now we got small letter r is equal to K. Okay, we got correct answer. Yes, Dhruv will for it. Fine. So A raised to 0 and B raised to 0, which means the value will be 1. So K into 1 is K. Now we got R is equal to K. So correct option is A, 0 order. So in 0 order reaction, rate is equal to rate constant. That keep in mind, it's an important concept. Okay, so yeah, yes, Nathan, Sania, very good. Abdul Rahman, good. Yes, Reshma. So many correct answers are coming. Good, good, well done, good. So almost all sent the right answer for this one. Yes, this is another logic in which order rate and rate constants are equal means you have to keep in mind in zero order. Okay, fine. We can go to the next one. Question number 7. Yes, that's an easy one. I don't think any doubt related to that one. Okay, fine. Now we can go to the next one. Question number 7. See, if the rate constant of a first order reaction is another numerical based one, but not a difficult one, we can say this comes under a moderate. Okay, question can be categorized as a moderate question. If the rate constant for a first order reaction is K, generally they are saying rate constant is K, then the time required for the completion of 99% of the reaction is given by. You know that one, we have an equation for first order. Okay, so for first order reaction, we have the equation K is equal to 2.03 divided by T log concentration of R0 divided by R. This is our general equation for first order, K equal to 2.03 by T log R0 divided by R, isn't it? So time required for 99% we need to calculate. You know that one, this type of question. So 99% means we will be taking the initial concentration always as 100, because percentage based on 100. So whenever they are talking about any percentage, you have to take the concentration, initial concentration as 100. Clear? Then what is the final concentration R? Final concentration means, okay, don't make mistake over here because they said 99% is over. You know that one, for 99% completion means that is over, that much substance has been used up. So what leftover will be 1. Am I correct? So leftover will be 1. That value we need to substitute, and it's an easy one, numerical, means the value can be easily solved. So we can write it as is equal to 2.3. So here they're asking the time, so we can write the time. So time t equal to, if you are rearranging this equation, k will come down. So 2.03 divided by k log, what is the initial value? Initial value is log 100 divided by 1, isn't it? So we can write that is t is equal to 2.03 divided by k. Log 100 can be taken as log 10 power 2. Same only, log 100 can be written as log 10 power 2. That you are expanding this one, log 10 power 2 means, you know that one, it's in the form of log a raised to b. Log a raised to b can be written as b log a. So t is equal to 2.03 divided by k into 2 log 10. You know that one, right? 2 log 10. You know that one, log 10 is equal to 1. Log 10 value is 1. So just you have to multiply. That is 2.303 into 2 divided by k. So 2.303 into 2 is equal to 4.606 divided by k. That's our correct answer. 4.606. Who all are? Yes. Very good. So yeah, we got so many right answer. So correct answer is 4.606 divided by k. So the correct option is D. Okay. So this type of one numerical you can expect, because the values are very easy. You can easily solve. Okay. No need to do that complicated numerical solving or anything, because log 100 is coming means you can write it as log 10 power 2. Log 10 power 2, when you are expanding, you will get 2 log 10. Log 10 anyway 1. So fine. So you'll be getting this one. Hope you understood. Yeah, almost all gave the correct answer. Well done. Hadia, well done. Nitin, almost, yeah, okay. Shadil, good. Okay. So now this one, option is D. Now we'll go for the next question. Okay. See, question number 8. The question number 8 is, a reaction is 50% complete. Okay, 50% of the reaction means, you know that one, half-life period only they are giving. 50% of a reaction is completed in 2 hours. Okay, and 75% complete in 4 hours. The order of the reaction is. You can send the right answer. Here also no need to go for any equation and all. I'll give an easy idea, an easy trick. how to find the order for this one. It's quite easy because you know that one. See, every first order reaction you keep in mind is for every first order reaction, okay, which remains the same, T half. For every first order reaction, T half remains same. Remains the same in the sense for 50%, T half remains the same in the sense for every 50% completion it will be same. Unlike zero order. Zero order we learned one thing, when initial concentration is double, half-life will be double. Okay, but here it is different. I'll show you how it happens. So 50% completion means we can write from 100 to 50. Okay, see here the time is given. Let us say this is 2 hours. 2 hours. Then 50 to 25. See, if it is a zero order reaction means you know that 100 to 50 means the difference is 50 is there. Okay, but 50 to 25 means the difference is 25 only. But in first order reaction, from 100 to 50, speed or rate can be taken as x. If you are taking as x, then what about from 50 to 25? 50 to 25, the speed is equal to x by 2. You know that one, if speed getting halved, what happened to the time? Time will be doubled. That is why again we will be getting 2 hours over here. Okay, isn't it? 2 hours. Because actually the difference is 25 only, but speed has been reduced as half. So the time will be double. So 25 is the difference means we are expecting 1, but speed is x by 2. That is called first order reaction. First order reaction, when concentration double, rate become or speed become double. Concentration halved, rate become halved. So after 50%, the speed will be x by 2, isn't it? So we have 2 hours over here, 2 hours over here. That is what in 4 hours they said. See, 75% completion means correct only. See, here to here, how much has been completed? 100 to 50 means 50% has gone. So till this 25 means 75% has been completed. Okay, 75% has gone. So that is only they are asking. So 75% 4 hours is taking. Which means this is in which order? First order. So correct option is A. Yes, almost all gave. I think yeah, few students got different, but majority. So someone said not zero order. Zero. That is why I explained very clearly. Don't make a mistake next time. This type of one question you can expect upcoming board. Okay, because this is a logical based question. In first order reaction, T half remains the same. That always you keep in mind. We did one zero order reaction. There T half will be changing because it's directly proportional to initial concentration. Here not. Okay. So here next to 25% also the time, because speed. That's why I wrote over here speed became halved. Then you know that when speed became halved means automatically time will be double. That's why we got 2. Yes. Correct option is A. Okay. Fine. So now the 8th question is over. I think no doubt few sent wrong answer, but now I think it's clear. Fine. Shall we go to the next one? Yes. Abdul Rahman, Sania, Nitin, Hadia. Yes. Okay, fine. Yes, yeah, Nitin. Okay, we can go for the next one. Fine. Question number 9. Yes. This question, it's a based on plot or based on graph. We have one question. You know that one, so many previous board paper you might have seen the same type of question based on graph. Here it's 2 graph clubbed, okay, or they can ask separately also. Anyway, we are going to do this one. This is not an easy one, okay, because one reaction we need to change it. Listen. Okay, you can send your answer. Finally, we can check. Okay, at the same time you have to listen how we can find out the order of this one. See here, which of the given orders are shown by the graphs respectively. Here graph A, I think it's visible to you, and graph 2 are given. For the first graph, orders are given accordingly, and for the second graph, orders are given accordingly. Anyway, first 0 and second order only will be given as per the syllabus. Let us see the first one is in which order. After that we can go for the second one. See the first one, how we can solve this type of question. See here in the y-axis log r is given. That log is, I think it's visible, this is natural log. Log r versus, I'll tell you how to solve this one. Log r, concentration of r versus t is the first graph. So this one is natural log, you know that one, not the base 10 log. But we can convert it to this one very easily, no need to memorize this equation. I will write the general equation and we'll go back to that natural log. Let's see how we can solve this one. See, we have the general equation k equal 2.03 divided by t log r0 divided by r. This is our equation. See how this 2.03 came? That is because we converted ln log into log log, log base 10. That's why we are multiplying 2.03. So you can ignore 2.03 if you are writing that natural log ln. So I will write this equation as k equal to 1 divided by t ln. I converted, okay, log r0 divided by r. Now what I am going to do is this equation I will make it as the equation of straight line that you know, you learned y equal to mx plus c. Okay, so now we can convert this equation as y equal to mx plus c form. I can take t to the left hand side. So I will get kt. Kt equal to, you know that one, here we have log a divided by b. What is the expanded form of log a by b? Whether it is log or ln, logarithm rules are same. So log a divided by b can be written as log a minus log b. So I will write log concentration of r0 minus log r. Correct. Then you can keep this minus log r over here. I'm going to rearrange again. Minus log concentration of r is equal to kt. Okay. This will comes to the left hand side, means that will be negative minus log r0. Hope you understood the step. Okay. Minus log r is equal to kt minus log r0. Now I'm going to reverse the sign. Okay. Then the magnitude will remain the same. So if you are reversing the sign, I can write log concentration of r is equal to minus k into t. Anyway, time will not be negative. Here this one became plus, then this is positive, became negative, and this will be plus log r0. Clear? Now this equation is in the form of y equal to mx plus c. While writing itself you will get the idea. This one I converted to y equal to mx plus c to get a clear idea. Okay, there should not be any confusion in this question. Okay, next time when you get the same in board question paper, so you can expect a graph based question. Now you have, see, y equal to mx plus means what we are taking the y-axis, y-axis log concentration of r. That is same over here. See, y-axis we have log concentration of r. X-axis what we took, it's t. See, same. See, x-axis we have t. See, this is t. So if you are taking log r in the y-axis and the t in x-axis, slope is equal to minus k. That only they gave. See, k equal to minus slope means slope equal to minus k. Same only. So now we understood this is first order. Because we started this one from first order reaction only. Okay, so this is the first order equation only we used. So that is the first order equation, k equal to 2.03 by t log this one. Okay, fine. So the same way we can go for the second graph. That is also quite easy. That is anyway based on log. I think this is visible to you. In the y-axis it is given log r0 divided by r. Okay, this graph might be very familiar to you, the first one. But the second one, you know that one is there, but not that familiar. Log concentration of r0 divided by r. So in the y-axis, they gave log concentration of r0 divided by r. We can say versus time only t. That is the next graph. So log r0 divided by r versus t. So that we can use the same equation. You know that one. We have the equation k equal to 2.03 divided by t log r0 divided by r. Again you can rearrange the equation same like how we did for this one. I will write kt. Okay, so kt is equal to this one 2.03 you can take, because log again the same way we are going to expand. Okay, so I can write as KT divided by 2.03 if you are taking is equal to log, this one if you are expanding, log R0 minus log R we will be getting, because log A by B is equal to log A minus log B. Okay, so I'll keep this minus log R over here, then I can write minus log concentration of R. This part is visible, I think. Minus log concentration of R is equal to K divided by 2.03 into T. 2.03 was in the numerator, so this will, when you take to the left hand side, it will be in the denominator divided by T. So K by 2.03 into T, this when comes to left hand side, it will be negative, minus log R0, correct? Minus log R0. So if you are rearrange, means reverse the sign, same way how we did for this one, then I will get log concentration of R equals minus K divided by 2.03 into T. Okay, T anyway now will be negative, minus K divided by 2.03 into T plus log R0, correct? Plus log R0. Again we made the equation in the form of y equal to mx plus c, straight line equation, y equals to mx plus c, correct? In this equation, okay, sorry, here we can do one thing, no need to take this one you can keep it as, yeah, better this one, they are asking to use this one on the same side, I'm sorry, this one you can write on the same side, which means, yeah, see this one you can keep it on the same side, then the next equation, no need to expand this one, we can write like this one, log concentration of R0 divided by R is equal to K divided by 2.03 into T. This much only require. Log R0, this one I kept as same. Log R0 divided by R is equal to this one on left hand side, KT by 2.03 into T plus 0 I will write. Plus 0 means just to make it as y equal to mx plus c. Now I got y equal to mx plus c, correct, right? So y axis what came? Log concentration of R0 divided by R came. Slope equal to K divided by 2.03 I got. X axis we are taking time, see. So here it is given, slope is equal to, here it's given, slope equal to K divided by 2.03. So I told you this question is not an easy one. Two questions actually we did together, that's why it takes time. Okay, but both the type of question you can expect, that's why I selected this one. Either the question based on the first graph or second graph you can expect. Hope you understood. Yes, correct option is which one? Option C. Both are in first order, so option C. So while seeing the graph itself, you will get the idea, because whenever log R0 divided by R is are plotted against T, keep in mind slope equal to K divided by 2.03, which means it's first order. So this one I explained to get the logical idea based on the first order equation. Okay, so based on the first order equation, we proved that one, this one is first order as well as this one is first order. So correct option is C only. Yeah, I think, yeah, Nitin, Reshma, yeah, so many sent the correct answer. I think you got an idea if you are getting the same type of question for the next time based on graph, how you will be solving. Okay, most of the time the question will be based on this first order reaction graph only, this one. So that is a very repeated question in previous board question paper, you can see. Okay, fine, hope you understood. Yes, Sania, good, fine. Now we will go to the next one. Okay, this is the way we'll be solving this one. Fine. Question number 10. So question number 10 is, in pseudo unimolecular reaction, you know what is pseudo unimolecular? See, options are given. Pseudo unimolecular in the sense, you know that one, in a reaction, if one of the reactant is excess, in the sense, you know that one, reaction rate is directly proportional to the concentration of reactant, isn't it? So in case of a reaction in which if you are taking one of the reactant as excess, then the concentration change is what? Negligible. So if one of the reactants concentration change is negligible, excess concentration if you are taking means concentration change is negligible. Concentration change is negligible means it will not be affecting the rate of reaction. So rate of reaction will not be affected if concentration of any one of the reactant is excess. That is the basis of the question. You know that one, we have a question, a reaction like this one, pseudo unimolecular. For example, an ester, CH3COO C2H5, okay, plus H2O. An ester when hydrolyzes, you know that one, in presence of few drops of acid, you will be getting CH3COOH plus C2H5OH, isn't it? So in this reaction, you know that one, the actual rate law equation is R is equal to K into concentration of CH3COOC2H5 only we will be considering, because water is taken as excess. So the concentration change of water will not be affecting the rate of reaction. That is why this reaction is called pseudo first order reaction, as well as you can call it as pseudo unimolecular. Actually, two molecules are there, but one of the molecule, the concentration change will not be there, or the concentration change is negligible. It will not affect the rate of reaction. So that is pseudo unimolecular reaction. Then, you know, when you are going through the option itself, you will get the idea. One of the reactant is present in excess, because both the reactant are present in low. No. Both the reactants are in same concentration. No. One of the reactant should be in excess. That is what we call it as pseudo unimolecular. Example, two examples are there. Actually, I wrote one example. Hope you understood. So yeah, yes, all you gave the correct answer. Now we can go to the question number 11. Now these are direct question. We can categorize as easy one. Which of the following is incorrect about order of reaction? Here I think it is quite easy. You can go through the option and send your right answer in chat box. Let's see who all are sending right. Yes, Hadia, yes, fine. Which of the following is incorrect about the order of reaction? So order of reaction, you know that one we learned. We have an equation, rate law equation, small letter r equal to K into concentration of A raised to X into B raised to Y. Even though the coefficients are A and B, we are taking X and Y because it's an experimentally determined. Order means it's an experimentally determined quantity. It can be zero or fractional, and it is the sum of the powers of the concentration terms in the rate law equation. Yes, now all are sending right answer. Yes, well done. See, it is calculated experimentally, correct. Incorrect they are asking, keep in mind. It is sum of the powers of the concentration in the rate law equation. Yes, that is order. In this one, order equal to X plus Y, correct. The order of the reaction cannot be fractional, wrong. We have fractional order reaction, isn't it? Fractional order reaction we have, for example, H2 plus Br2 gives 2HBr. In this reaction, we cannot find a reaction, means we cannot predict the order of a reaction, but this comes under fractional order, small letter r equal to K into concentration of H2, but Br2 concentration raised to 1/2. Concentration of Br2, the power is 1/2, that's the way it affects the rate. So the order is 3/2 actually here. That is, the order is equal to 3/2, isn't it? So this one is a fractional order. So correct answer is C. Cannot be fractional, they are saying, wrong. Now question number 12. A reaction involving two different reactants can never be. See, it's a different question, but based on the pseudo first order or unimolecular. Okay, pseudo unimolecular. See, a reaction involving two different reactants. Two different reactants means it never be unimolecular. It can be pseudo unimolecular. It can be what? Pseudo unimolecular, but never be. It can be pseudo unimolecular, but never be unimolecular. Keep in mind, because two reactants are there. Why we call it as pseudo unimolecular? Because one of the reactant we are taking as excess. That's why pseudo unimolecular. So otherwise never be unimolecular. Yes, correct option is Sonia. Yes, correct. So correct option is A. It can be a first order reaction, no doubt. It can be it is bimolecular. Okay, two different means. It can be second order, no doubt, but it never be unimolecular. Now we can go to the question number 13. These are theory based, so we can go easily. The rate of a reaction can be increased in general. So in which all cases the rate of reaction will be increasing by all the factors except, okay, except which one? You know that one, if you are using a catalyst, rate of reaction will increase. Increasing temperature, that we learned in the same chapter. for every 10 degree rise in temperature, isn't it? 10 degree rise in temperature, rate of reaction will be double. Okay, right. So in every reaction, when you increase the temperature 10 degree, rate of reaction will be double, so temperature will increase. Increasing the activation energy, wrong. That is, increasing the concentration of reactants will increase. So this is our correct answer, because they are asking except. Why activation energy will not affect or is indirectly proportional to rate? You know, we have an equation, log K is equal to log A minus EA divided by 2.03 RT. This is the expanded form of K equal to A into E raised to minus EA divided by RT. This is the Arrhenius equation we learned. The mathematical relationship between temperature and rate. So mathematical relationship between temperature and rate means K equal to, K is nothing but it's a mathematically rate only. So K equal to A into E raised to minus E divided by RT. Here in this equation you will get an easy idea. K is nothing but it is mathematically rate only. Rate constant is mathematically rate. So rate and EA, what is the relationship? Inversely proportional minus EA, which means minus EA and K, rate constant is mathematically rate, inversely proportional. So when activation energy increases, rate decreases. So by the equation itself we can say, so increasing activation energy means rate decreases. That is they are asking. So who all gave the correct answer? So yeah, so many gave the correct answer. So increasing the activation energy is the only exceptional, means except this one, remaining all reaction rate will be increasing. Question number 14. See, question number 14, a first order reaction is 50% completed in 1.26 into 10 power 14 seconds. How much time would take for 100% completion? See, while reading the question, you will be thinking that this is numerically solved one. Actually not. Can you send the answer in chat box? Let's see who all have idea about this question. See, here the correct answer is, yes, Abin, well done, good. Hafiz, yes, well done, good. Here the correct answer is D. Why I choose the option then going for the explanation? Because I'll tell you, a first order reaction means I told you 100 to 50. Okay, if this is the time 1.26 into 10 power 14, then 50 to 25 will take the same. 25 to 12.5 will be same. 12.5 to 6.25 again will be half. This way it will be going. So for 100% completion, it's not able to find the exact value. You can see while going this, this way itself you will get the idea. 100 to 50 the same, 50 to 25 the same time, 25 to 12.5 the same time, then 12.5 to 6.25 it will be the same time, and again the half of 6.25 you can write, okay, that again over there, then it will be decreased. So 100% if they are giving means it's impossible. 99.99 till that we can find out. Okay, that is approximation, we can do that one. 100% means it is infinite. That always you keep in mind. That's why in the reader we have question for 99.99, but 100% means always keep in mind infinite. Yes, almost all send the correct answer. Fine. Now we will go to the question number 15. Another question. A hypothetical reaction A2 plus B2 gives 2AB. Follows the mechanism as below. You know that one, a reaction having mechanism means such reactions are called complex reaction. So why they gave this question? It's a NCERT based question only. This one because there are elementary as well as complex. So they gave a complex reaction and they are giving the mechanism means each steps are elementary. So listen carefully, this one comes under a categorized as a difficult question. Okay, this question. So few of the question you have to practice like that one. So here in this reaction the steps are given. So what is the general equation? General equation is A2 plus B2. Okay, A2 plus B2 gives 2AB. See, if you have an equation like this one, you know how to write the rate law equation. Small letter r equal to K into concentration of A2 into B2. then we can write it as concentration of small letter r equal to k into concentration of A2 raised to x into B2 raised to y. We will be writing like this one. But you know that one, we have to find out the order. That is actually a question. How we can find out the order from the steps or mechanism? Whenever they are giving the mechanism, keep in mind each steps are elementary reaction. So we have to focus on two elementary steps. One is this slow step as well as the reversible reaction. Always rate law is applied, or rate law can be applied only for the slowest step. Okay, that is why yes, it is called rate determining step. Well done, rate determine. But we will not get the direct answer over here, because rate law, rate determining step is A plus B2 gives AB plus B. This one, if you are applying rate law, it's an elementary, means we can take the power as unity, that you know small letter r equal to K into concentration of A into B2. But see, in the actual equation we have A2 and B2. In the elementary we have A and B2. So we need to substitute A, because if we have A2 over here, then it's fine, because equation is A2 and B2. For that one we are going to use the equation, the first one, because this reaction is a reversible one. Reversible one means we can apply the equilibrium constant. So what is the equation over here? A2 reversibly gives A plus A plus A. In this one, I will apply the equilibrium constant. So equilibrium constant, if you are writing, you can write Kc equal to A concentration into this one, A concentration into A. Okay, I can write A square, A raised to 2 divided by A2. From this one, I can take the substitution of A. Then A raised to 2 means concentration of A will be what? Root of Kc into A2. Correct, Kc into A. This I am going to substitute into this equation. This one I will take it as equation number 2. So substituting into equation number 2, what will you get? Substituting into equation number 2, you will be getting small letter r is equal to K. I will take it as same. Here I have, instead of A, I have root of K into A2. Okay, inside the root only, into B2 will come. Anyway, B2 value is 1, because it's an elementary step. The power can be taken as unity or 1. Now is equal to K into K root means we can write, or Kc, it is Kc only. Kc, root Kc means I can write Kc raised to 1 by 2 into A2 raised to 1 by 2, correct? Root A2 means A2 raised to 1 by 2, A2 raised to 1 by 2 into B2. B2 power anyway is 1 only. You know that when two constants, when you are multiplying, you can take it as a general constant K. K into A2, isn't it? A2 raised to 1 by 2 into B. B means B2, same B2 raised to 1. You know that one. Now we have the power, that is order is equal to what? 1 by 2 plus 1 is equal to 3 by 2. 1 plus 1 by 2, or 1 by 2 plus 1 is 3 by 2. Yes, 3 by 2 is the right answer. We have the correct option over here, 3 by 2. Hope you understood. Yeah, so many, yes, C option, many of you have sent the correct option. Fine. So one more question we will be doing. Okay, so 15th one, this one, you know that one is, some of the few questions are numerical based. So if you have an idea of how to solve that one, it will be helpful for your upcoming board exam, because same type of question you can expect. Hope you understood this one. We will go for the next one. One more question we can solve. Yes, that is an easy one, direct one. See, for the reaction H2 plus Br2 gives 2HBr. Okay, so for the reaction H2 plus Br2 gives 2HBr, the reaction rate means the rate law expression is given. So what is the rate law expression given? Rate law expression, small letter r equal to K into concentration of H2 into Br2. This is what the same example I gave before, Br2 raised to 1 by 2. Rate law expression as given. So which statement is true about this reaction? Okay, which statement is true about this reaction means here you know that one, order can be written as, order is equal to 1 plus 1 by 2, anyway that is 3 by 2 order. So what is the molecularity? Order is equal to 3 by 2 molecularity. Molecularity is a direct value, you know that one. Molecularity is theoretical. Yes, Dhruvil, yeah, half is well done. Molecularity is a theoretical value. We will be taking the sum of the coefficient. So here the sum of the coefficient means, according to the equation, H2 is 1. So 1 plus 1 is equal to 2. So molecularity is what? 2. The reaction is of second order. Wrong. It is 3 by 2 means fractional order. Molecularity of the reaction is 3 by 2. Wrong. Molecularity never be fractional. Only order can be fractional. Molecularity never be fractional. You know that one. Molecularity is a theoretical value, because in balanced equation there won't be any fractional value. So molecularity of the reaction is 3 by 2. Wrong. Unit of K is second inverse. Wrong. That is in first order only. Okay, first order only. Unit of rate constant will be in second inverse or minute inverse. Time inverse means that is for first order. Unit of rate constant. So molecularity of the reaction is 2. It's a direct one anyway. Molecularity of the reaction is 2 we got. So that is D. So correct answer is D. So almost all type of the question we came across in this chapter. You know, this is a physical chemistry chapter. Numericals questions are there. Yes, Dhruvil, correct. 1 plus 1 by 2 according to the rate equation. Yes, yes. 1 plus 1 by 2, 3 by 2. So order is 3 by 2, but that order is not given. They are saying molecularity is 3 by 2. So correct answer is anyway molecularity. So almost all type of question we did. So this type of question you can practice. Many of the questions are from previous board question paper. So hope you understood some logic, theory based, that first order, zero order reaction based logic, as well as some numerical based question. So guys, thank you so much. See you on next class. Next session we will be meeting on next chemistry session. Thank you so much. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.